This time I'm gonna start with just a blank XPresso canvas and then introduce the PLight node. PLight node is here to give you access to different properties of a certain light. So let's quickly give it a light source to use. And why would you use this node at all? For example, you can build a complex rig including hundreds or maybe thousands of MoGraph objects. And let's say visibility of those objects is gonna be fully dependent on light intensity in certain point of space. So let me quickly give you an example of the way it might look like. First I'm gonna add the light intensity output here. Then I'm gonna quickly add a new null object to this scene. It's gonna be placed right in the middle of a scene by default. I'm not gonna move the null, but I do want to move the light source instead of it. Then I drag that null onto the canvas and connect it to the PLight node via global position port. So right now we're basically telling this PLight node to extract light data from a place where the null one is. Then let's see what we've got by connecting the intensity output to result node. And it seems like we have a constant result of 1 despite of the actual distance between this light and null 1. And it's all because of this fall-off parameter of the light source. Let's quickly go ahead and switch it from none to inverse square. And this time you can really feel the difference by watching the result node while moving the light source around. So that was just a basic idea behind this PLight node. Now let's quickly make some more room here by highlighting all of these guys and dragging them a bit aside. And then finally build something more complex here. I'm gonna quickly create a few more clones of this cube by putting it into cloner object, then go deeper into this cloner's options and switch the mode from linear to grid array. We definitely need to work with this cloner object, so I drag it onto the XPresso canvas and add the object output to it. Next we gotta tell the XPresso that we want to work not with just a cloner object itself, but with each of individual clones this cloner object contains. And we can easily do this by grabbing the data node, which is responsible for such operations. First let's connect this node to cloner via the object ports, and then we gotta iterate through all the clones it contains. First I'm gonna duplicate these two nodes to start building the iteration chain. So far we have the information about how many clones exactly do we have, and we need a math node to subtract 1 from that count value. So let's quickly change this node's function from add to subtract and then connect these nodes together. I'm gonna do this using count port and then increase the input 2 value up to 1. Now when we got the correct value to iterate through, I'm gonna go to new node, XPresso, iterator, iteration node. Let's connect the math node's output to iteration node's iteration and input. And then let's link this iteration node to the index input of data node. So now we know the cloner we want to work with. We iterate through all of its clones correctly as well. And we would definitely like to extract information about those clones' positions. At this point it looks like we don't need any information about null one's global position anymore, so I'm gonna get rid of it. And let's connect data node's position output to the PLight node's input. That's giving us the light intensity values for each of those clones. And it looks like the nearest clone to the light source experiences the intensity of something around 1.5. So let's use this compare node to tell those clones when to hide and when to be visible again. I'm gonna increase its input 2 value up to 2 and set the function to greater than, meaning that I want all the clones which intensity level is beyond value of 2 to become hidden. So right now we do keep track of such clones, but we gotta transfer this information to somewhere. And it seems like we gotta use something what's called a MoGraph selection to make it working. Let's go to MoGraph selection and highlight at least one of those clones. You can see right there the MoGraph selection tag has appeared in the object manager. So let's use it by dragging it to the XPresso canvas. We can quickly add the object output to it, but this tag by itself won't give us much. We gotta use another node to combine it with information about the clones we are tracking so far. So let's right click on the empty field, go to new node, motion graphics, MoGraph selection, and it looks like that's our guy. I'm gonna add the input called select here, then connect both of these MoGraph selection nodes via selection tag input, reuse that iteration node for index port, and finally use the compare node to set current selection. So we've done a good job creating this XPresso rig, and it looks like it's just about time for some finishing touches. Let's highlight the cloner and add the plane effector to it. Then quickly go to its parameters and switch to Effectors tab. Grab the MoGraph selection tag and put it into selection field right there. That way this effector will know which selection to use. Then go to its parameter tab and turn the position checkbox off. But don't forget to turn on visibility checkbox instead, since that's the one we're looking for here. And here comes the very finishing touch. Let's go to the Effectors tab back again and decrease the maximum value to something around 20%. And that's it. Now if I try to move this light source around, these clones will start to hide and appear depending on the light intensity value. And keep in mind that right now this light intensity threshold is set to 2. And you can always come back to Compare Nodes parameter tab and change it from 2 to anything you want. And the whole rig will react appropriately. So, and that was just one of the things you could do with the help of XPresso. And that's the PLight node. And if you really like these XPresso tutorials, you can find the whole course devoted to XPresso available on the App Store. Just type in XPresso or follow the link below.